Hi, welcome you all. I'm going to explain you about the standard normal distribution, a worked example. I'm Ishan Veeratunga. Standard normal distribution table, it's a bell-shaped one with having a area of 1. It differs, it is spreading between -3 to +3. It's a symmetrical bell-shaped curve. What does this mean? So it means Z is a hypothetical value of the standard distribution. The mean of this one is 0 and sigma is the standard deviation. So accordingly, this is a model, hypothetical model. From the real life scenarios, we can create this one as a standard normal distribution. From this one, there is a standard values for Z from -3 to +3. So you can follow according to the chart. Then the figures will be shown in the example. So we'll take a couple of examples and real-time scenarios how to make this one. First of all, we need to know how to read a normal distribution. We'll take Z as 1.2. We know what the normal distribution is. Here it says as 0.3849. So it means the area of the curve between 0 and 1.2 is 0.3849. So this is assuming that the total area under the curve as 1, so that we can come it as a proportion. It's 38.49. But what does it mean? If we want to get the probability of values less than 1.2, we have to go to the left hand side as well, so that the left hand side of this curve is 0.5. Then we have to add 0.5 plus 0.3849. It's about 0.8849. 88.5 is the percentage. So this is the less than 1.2. What if we want to find out is it more than 1.2? It is very simple, because we know the total area of this curve is 1. We can tabulate 1 minus 0.8849, then it becomes 0.115, 11.5. It is, you can visualize beyond the 1.2, the right hand side portion will be 11.5. It is very sensitive. But now the real problem starts. In the scenario, in normal real life problem, this Z value we had to define, we had to derive from the X value. Can you see our problem when it comes to real life? We'll go to the next example. How do we map the X world into Z? X is the real life sum, Z is the hypothetical normal distribution. To go to X to Z, we can use the table. Yeah, there is a simple formula. That simple formula is Z equals X minus mu over sigma. X is the score minus mean divided by standard deviation. Now, if we want to understand it more clearly, we'll take an example. We'll take a real-time scenario. The question is like, the heights of students are normally distributed with a mean height of 1.7 meters and a standard deviation of 0.1. What percentage of students will be taller than 1.87 meters? Of the 700 students, how many will be shorter than 1.87? Now, what are the data given here? Mu is given 1.7, sigma is given 0.1. So, without calculating anything, we can see what are the data. Other data is given. 1.87 is the value of our X value, where we want to distinguish a difference. We want to select a section more than 1.87. How do we do? Now these are the steps actually. Idea, we have to understand what does the question is, and we have to develop a solution. So this is for all about planning stage. In any mathematical or any example, don't jump into solve the equation, or don't jump into solve the problem. First of all, you have to understand, and you have to put it into a graph or kind of a table or a sketch you have to draw. Then you will see what they are asking is. So otherwise you will be spending unnecessary time in repeating and taking lot of unnecessary unwanted information. So we have target for the question and answer. Here data is given, mu is 1.7, sigma is 0.1 and the x value is 1.87. It is simple, the data in the x value. Now we have to draw them in an Z curve. So as an example, if it is 1.35 or likewise, we can draw it in the left hand way. But now what we know is only one data we have with the Z table, Z chart, bell shape normal distribution curve. We know 68.2% will be lying within mu and sigma and 95% will lie within mu and 2 sigma. So then we have to distinguish. First of all, we have to just calculate mu plus sigma. How much? 1.7 plus 1.7 plus 0.1. It is 1.8. But the x value is 1.87. Those are the data is given here. So then it is not there. We have to go more than that to meet 1.87. Then mu plus 2 sigma. 1.7 plus 0.1 into 2, it means 1.9. Okay, this comes 1.9 and 1.87. This is the area where we can see here it's really 95.8, 95.4. With this one we can come to a conclusion. Okay, what they are asking is regarding this yellow part. Yellow part is the one which is lying. So that is an example. The answer will be taller than 1.87, means this red part, something like that. It will be about 5%. Before solving the sum, we right now have an assumed answer. We have an guessed answer. We can estimate that will be about 5% or closer value to that one. So we will see how we can tabulate that. Steps. Then we are going to solve it. We are going to evaluate the problem. What we know is translate the x data into Z world. Z equals x minus mu over sigma. What we know is x is 1.87 minus 1.7 divided by 0.1. So it is 1.17 divided by 0.1. It will become 1.7. But what we ask is the corresponding value of 1.87. Now we have gathered it as 1.7. In the table, we can see what is the 1.7 value. It is 0.4554. So what do they ask? They are asking is more than 1.75. Then in this Z table, we can sketch what is the value of more than 1.75. 1.7, sorry. It is 0.4554. The answer from the table we have got is 0 to 0 Z 1.7 is 0.4554. What does it mean? Can you remember earlier one? We wanted to calculate Z less than 1.2. Similarly, what we need to do is here more than 1.7. Then what we have to do is 0.4554 is the value within the 0 and 1.7. Similarly, more than 1.7. What we have to do is we have to reduce that value from 0.5 minus 0.4554. The answer is 0.446. Look back the original estimate. So earlier we thought if 5% means 0.05. Now here it becomes 0.0446. It is very close to that one. Now read the question and give the real answer. What they ask is the estimate the percentage of value more than that. It means 0.446 multiplied by 100. It is 4.46. So the probability that the student is taller than 1.87 in a normal distribution curve, which having mean of 1.7 and standard deviation of 0.1 is 4.46. Very simple. Is that all? Are there anything that we have to do again? No, we have not finished. That's another part. What is the B? How many questions for how many students we will have? In that question, probability and the number. In this case, we want to know how many are shorter than 1.87. Oh, what did we do? We did how many are taller than 1.87. It is very simple. Our table gives 0.4554. What else we can do? add 0.5 because the left hand side curve of that one, then it will be 0.5 plus 0.4554 means 0.9554, that is multiplied by 700, 668.78. Number of students cannot be 668, we can round it off, we can say it is 669 students are shorter than 1.87. It is very simple, isn't it? This is the way to do examples. We'll go for another question. The Christmas tree problem, I'm not going to solve this one. As you know the methodology, you can solve this one, but I will give an approach first of all. The length of a Christmas tree branches from a pine tree plantation can be assumed as normally distributed with a mean length of 1.8 and standard deviation of 20 centimeters. What percentage of branches would measure less than 2.7? If there were 80 branches, how many would be expected less than 2.07? It is very simple. Earlier 1.7, here it will be 1.8 is the length. Standard deviation 20 centimeters means 100 centimeters in 1 meter, 0.2. Then the less than 2.87, like earlier it was 1.87. So simply we can do, I'll give kind of a figure for this one, mean, standard deviation, then how can we conclude that one to a Z score with the table, then you can do with the diagram. It is very simple, not that difficult. You can carry out next steps 5, 6 and 7. What are the values in the real life answer? I have given you the final answer as well. You can do it. I hope once the step 9, 10 and 11 also you can do. These are the questions. I hope you can manage by yourself. So normal distribution, we have made it easy. I hope you can meet any type of question in the exam which we encounter. These are the standard types of questions you will get. If you can do these two questions correctly, no problem at all. 20 points are guaranteed. Thank you very much.